Welcome to VK Tutorials. In this video, you will learn about equations of motion related to motion chapter class 9 CBSE. Now let's start. There are three equations of motion. The first one is V is equals to U plus AT. S is equals to UT plus half AT square. And the third one is V square minus U square is equals to 2AS. Let us define each term from the following equation. This is our first equation, this is our second equation, and this is our third equation. Okay, let us define each term. Here V is the final velocity, U is the initial velocity, S is the total displacement traveled by an object, A is the acceleration attained by the object, T is the time taken or time period taken by the object. Okay, now that we define each term, V is the final velocity, U is the initial velocity, S is the displacement, A is acceleration, and T is time taken. For better understanding, let us consider position A of an object. It has to move from position A to position B. Here's an object which is moving from rest. So this is its initial position and this is its final position. So at initial position, it will have an initial velocity u. Because it is starting from rest, it will have 0 meter per second, and it has to attain some final velocity at final position, that is v meter per second. Okay. From position A to position B, it has to move, so that in certain amount of time it has to move. So the time taken here will be some t seconds. The distance between point A and point B will be equal to S, or you can say displacement between A to B that the object has to travel will be S. Now when the object is moving, it will attain some acceleration. When the object is moving, it will attain some acceleration A. Okay, so this is the basic idea of what the equations of motions will be. It will help us to solve many numericals. Now we'll see derivations of equations of motion. Okay, let us start with the first one. V is equals to U plus AT. Similar to the above, consider an object at its initial point A and final point B, which is moving with a uniform acceleration A. So at rest it will have 0 meter per second, which is initial velocity, and it will have v meter per second, which is final velocity. Because it has to travel from position A to position B, it will have a displacement of S from A to B, which is traveling in certain time, that is nothing but t seconds. Okay, here is a basic figure to solve the following. Okay, as we know, acceleration A is nothing but change in velocity in certain amount of time. Here change in velocity is final velocity minus initial velocity by time taken. Therefore, we get A is equals to V minus U by T. The next step, AT will be equal to V minus U. From this equation, we can say V is equals to U plus AT. This is how we derive our first equation. Now we'll see about this derivation of second equation of motion. Derivation of second equation of motion, that is S is equals to ut plus half at square. Similar to the above description, consider a body which is moving with initial velocity u and attaining a final velocity v, which has to be displaced from A to B of a displacement s and time taken t. Total time to move it from A to B, which is moving from rest at an uniform acceleration. As we know, displacement S is a product of average velocity and time taken. Here, average velocity is equals to u plus v by 2. Initial velocity plus final velocity by 2 is equals to average velocity. Now, from the above, we can say S is equals to average velocity u plus v by 2 into product of into t, because it's a product of average velocity and time. From first equation of motion, we know that v is equals to u plus at. Therefore, S is equals to u plus v. In the place of v, we substitute u plus at by 2. In the place of this v, we have substituted u plus at. That is how we got this, which is again multiplied to time taken t. Here u plus u is 2u plus at by 2 into t. Therefore, S is equals to, if we multiply t, we get 2ut plus at square by 2. That is equals to, S is equals to, if I split the terms, 2ut by 2 plus at square by 2. 2 and 2 gets cancelled. S is equals to ut plus half at square. So this is how we derive our second equation of motion. Now let's derive the third equation of motion which also again has the same description. Consider the same body which is moving with uniform acceleration, initial velocity, final velocity, everything will be same. So I don't need to. Derivation of v square minus u square is equals to 2as. As we know, displacement s is equals to average velocity and product of time. Average velocity into time. So s is equals to, we know average velocity is u plus v by 2 into time is t. From first equation of motion, v is equals to u plus at, t will be equal to v minus u by a. So I'll substitute s is equals to u plus v by 2. In the place of t, I'll substitute v minus u by a. So s is equals to, we get u plus v and v minus u, nothing but a plus b into a minus b. So s is equals to v square minus u square by 2a. 2as is equals to v square minus u square. This is how we solve our third equation of motion. I hope all the three equations of motions are clear now. Thanks for watching the video. Please do subscribe and don't forget to press the bell icon. You can follow our Facebook page at vktutorials.in. Also our Instagram page vktutorials_. Log on to our website www.vktutorialacademy.com.